Welcome to the deep dive. Today, we're plunging into one of those really big questions, the kind that keeps you up at night. If there are advanced civilizations out there, somewhere in the vastness of space, why haven't we found any solid evidence? Like anything. It's the famous Fermi paradox. And our deep dive today is all about this paradox, but through a really specific lens. A unique German nonprofit, GridSAT Stiftung. They have this radical idea they call open everything, and they think it's crucial, especially now with all this talk about non-human intelligence, or NHI.
That's right. And what we want to unpack is why GridSAT believes this open everything isn't just one way forward, but maybe the only truly responsible disclosure policy. They argue it could help humanity navigate these potential dead ends, these great filters that might lead to self-destruction. And exploring this also forces us to think about what advanced civilizations, whether ours or others, might actually look like.
Exactly. So we'll be digging into their own statements, some recent research, and also considering a pretty chilling line of thought about what happens when science makes a truly world-altering discovery. It's kind of a journey into the future of knowledge itself. Okay, so let's start with GridSAT Stiftung. They're pretty new, right? Established July 1st, 2021 in Germany. And their whole mission revolves around this concept, open everything.
Yeah, and open everything for them isn't just, a slogan. It's really concrete.
Yeah.
It means open knowledge, open source software, open data, open access to research, open education, even distributed operations. And crucially, all completely free. Their stated goal is making formerly uncomputable solutions available, which is, well, it's a massive claim.
Formerly uncomputable solutions available for free. That's huge. And the reason they give is even bigger. They say it's to drive humanity forward, potentially even, get this, leveling off with non-human intelligence. What does that even mean, practically?
Well, it's definitely ambitious. The idea seems to be that by unlocking this level of computational power and knowledge for everyone, we can accelerate our own development. Sort of. Boost humanity's potential to a point where we're not so drastically behind any other advanced intelligence we might encounter, or that might already be here. And to make sure this open everything value proposition is secure and permanent, they're using some serious tech.
Okay.
Distributed blockchain technology. Think of it like, well, not putting all your eggs in one basket. They mirror everything globally using things like the Interplanetary File System, IPFS, which is designed to be decentralized and censorship resistant. And they use Ethereum smart contracts to basically lock down the rules, safeguarding the source code, the open repositories, the computation nodes. It's built to be immutable. As long as the internet exists, it exists.
Oh, wow. Okay. That's a serious commitment to openness.
Yeah.
Now, to really get why this matters so much to them, we kind of need to step back and look at the Fermi paradox again. Its origins are fascinating.
Right. Enrico Fermi, the physicist. It came up during his time at Los Alamos working on the Manhattan Project.
Like atomic bomb.
Exactly. So you have this intense environment, scientists grappling with creating technology with unbelievable destructive power. And amidst all that, Fermi and his colleagues are looking at the sheer scale of the universe and asking, where is everybody? If civilizations can arise and the universe is so big and old, shouldn't we see signs of them? That context, immense power, potential self-destruction is key.
So let's break down the paradox logically. Premise 1. The universe is vast. Insanely vast, like maybe 100 million habitable planets just in our galaxy, and trillions of galaxies out there, so the probability of life, even intelligent life, seems really high, doesn't it?
It certainly seems that way based on the numbers. That's premise 1. It's solid. But then premise 2 hits you. Despite those odds, we have, well, a lack of universally accepted, unambiguous evidence, no obvious signals, no confirmed visits, a great silence. And that's the paradox, the contradiction. Wow. And for years, the common solution, if you can call it that, was this idea of filters. Great filters, maybe life is rare, maybe intelligence is rare, or maybe, and this is the chilling part, echoing Los Alamos, maybe civilizations inevitably reach a point where they develop technology that leads to fatal technological development, resulting in necessary self-extinction. They just don't make it past a certain stage.
Okay, but here's where things get really interesting today. That second premise, one about no evidence, it's starting to look a bit shaky, isn't it?
It is. Recent empirical data, or at least public discourse around it, challenges premise 2 quite directly. Premise 1, the vastness and potential habitability, holds up. Kepler telescope data, and now Webb, keeps reinforcing it. But premise 2, you have widespread public discussion about UAP's unidentified anomalous phenomena. You have pilots reporting strange encounters. And significantly, you have sworn testimony before a U.S. House committee in July 2023 discussing potential non-human craft and intelligence.
So if we even entertain the possibility that some of this is real, if extraterrestrial civilizations exist and have reached a technological level enabling them to manifest here on Earth, then that immediately implies they possess technological capabilities far surpassing our own.
Absolutely.
Yeah.
It flips premise 2 on its head. If they're here or can get here, then there isn't an absence of evidence, just perhaps an absence of our full understanding or official acknowledgement. So, in a way, the Fermi paradox, as originally formulated, might be, well, obsolete if NHI are indeed present. The paradox dissolves because the condition of no evidence is potentially false.
But wait, does that mean we're safe? That we've passed the great filter?
Not necessarily. That's a crucial distinction. Finding out we're not alone, or that advanced NHI exists, eliminates one potential reason for the silence, that advanced life is impossible, or always self-destructs before reaching interstellar capability. But it does not imply a sufficient condition to prevent any civilization from self-extinction. We might just face different filters later on, maybe related to managing the very technologies that allow for such advancement.
Which brings us right back to GridSAT and their core technology, the Non-Deterministic Processor, or NDP, deployed, they say, with unlimited linear scalability on IPFS.
Right, and this is where it gets really mind-bending. At the heart of the NDP, according to GridSAT, the ability to solve the P versus NP millennium problem, P vs NP. It's one of the biggest, most fundamental questions in computer science and mathematics.
Can you break that down, P versus NP?
Sure. Roughly speaking, P problems are ones where finding the solution is fast, computationally. NP problems are ones where verifying a potential solution is fast, but finding it might be incredibly hard. Think like factoring huge numbers. Easy to check the answer, hard to find the factors. The question is, are P and NP actually the same class? If P equals NP, it means any problem where you can quickly check the answer, you can also quickly find the answer. And solving this, well, some have said it's more important than the discovery of fire.
Wow, okay. Why is it that big a deal?
Because, as one analysis put it, nearly every area of knowledge is based on the idea that brute force search is hard. We just showed that it's easy. Everything changes.
Okay, I need an analogy.
Think about finding one specific, say, red grain of sand mixed into millions of white grains spread across a huge beach. Searching for it seems impossible, right?
Yeah.
Might take forever.
Yeah, hopeless.
But what if you had a magic process that instantly melted all the sand into a single clear sheet of glass? Suddenly, finding the red speck is trivial. You just look. PNP, or a technology like the NDP that effectively achieves it, is like that magic melting process for computation. It makes finding solutions to problems previously thought intractable, fast, easy even.
And unlimited linear scalability. Does that mean the more computing power joins the network, the faster it gets without limits?
That seems to be the implication of GridSAT's statements. It scales with the network. And they claim this NTP power propels us into a future completely different from today. They talk about non-monetary transactions, zero marginal costs, and a vibrant culture of sharing.
Zero marginal costs. Like
Yes.
producing one more unit of something costs nothing. That dismantles current economics.
Pretty much. They say it can unlock the limitless possibilities of humanity. They list examples like developing any cure or vaccine with no more cancer or diabetes, ensuring quality food for all, even decomposing plastics with proteins, and enabling deterministic quantum computation. It simplifies the most complex challenges with unrivaled speed and precision.
Okay, my mind is officially blown. But let's connect this back. If NHI are real and capable of manifesting here with tech far beyond ours, then mastering something like this NDP, something that makes the supposedly uncomputable, computable, it seems like that would almost have to be a prerequisite, wouldn't it?
It certainly stands to reason. If you want to calculate interstellar trajectories, manipulate energy on vast scales, understand biology deeply enough for radical life extension or creation, you'd likely need computational power that makes P vs NP irrelevant. Mastery of something akin to an NDP seems like a necessary condition for that level of capability, implicitly including interstellar travel.
Which leads to a really heavy question. If we achieve this kind of power, how do we handle it?
Exactly. And this is where contemplating the pressure of such a discovery becomes, well, sobering. Imagine the scenario. A group figures out PNP. They think, great, this is for humanity. Or then maybe a government steps in, classifies it, calls it a national security asset. Why?
Because it breaks everything.
Pretty much. Think about cryptography. Almost all modern encryption relies on the assumption that certain problems are hard, that P does not equal NP. If PNP, and you have the method, then accelerated key search and decryption, means essentially the entire world is at your fingertips. There's literally nothing you couldn't see.
Financial systems, government secrets, private communications, all wide open.
It's described as being the equivalent of trillions of dollars worth of information. And from a military perspective, it's seen as a weapon. Maybe not a bomb, but something more insidious. Crippling communications, disabling power grids, manipulating financial markets, a penny here, a penny there, spiraling the world economy. It's framed as controlling the country's brain, or like a water-based toxin, subtly undermining societies from within. Far more subtle than nukes, perhaps far more effective in the long run.
So you have this immense power, and the immediate reaction from, say, established powers might be to lock it down, control it, weaponize it.
Right, the desire to lock this away for spying, for national advantage. But then you have the perspective of those who made the discovery, potentially thinking to lock this away so you can spy on somebody is criminal. This knowledge could solve so many real problems.
It creates this incredible tension around disclosure, doesn't it? The government argument might be patriotic duty, keep this power safe, keep it ours.
While the scientists might argue for sharing, for the good of science, for humanity, there's also the fear, perhaps, that if you keep it secret and something goes wrong, maybe another group discovers it and uses it destructively. The ones hoarding it will just wash their hands of it, saying, see, it wasn't our idea.
And underneath all this is the unsettling idea that, well, knowledge finds a way out.
Exactly. The implicit understanding that everything which can be known will be known, eventually. If PMP is true, the universe works that way whether we know it or not. And as someone in that hypothetical scenario might realize, the world is not as complex as you believe.
To think you're the only ones working on it?
Is naive. Someone else, somewhere else, might be close, or already there, which leads to that chilling declaration. The new Cold War has begun. A Cold War fought with information and computation, not just missiles. And the implication is stark. If this knowledge exists, suppressing it, keeping the public in the dark while others do know, that imbalance implies no good. It creates instability and risk.
Which brings us right back full circle to GridSAT's core principle.
Precisely. Their stance is unambiguous, they state. The NDP is and will always be public domain, tightly integrated into the web for a year, interplanetary file system ifs with Ethereum smart contracts, and as long as the internet exists, immutable and censorship resistant to the max.
So for them, this isn't just a preference. They see open everything as the only truly effective, responsible way to handle a discovery of this magnitude.
Yes, it's a direct counter-strategy to the secrecy and control model. By making it public domain, by embedding it in decentralized, uncensorable systems, they aim to prevent any single entity, government, corporation, anyone from monopolizing it. It stops it from being a national asset to be hoarded and potentially weaponized. Instead, it becomes a collaborative and social commons, available to all.
And this connects directly back to the Fermi paradox and those great filters.
Absolutely. GridSAT's open approach to making formally uncomputable solutions available is essentially their strategy to diffuse that specific filter, the one where we invent something incredibly powerful and then destroy ourselves with it through secrecy, conflict, or misuse. It's an attempt to ensure humanity doesn't fall into the very trap Fermi and his colleagues worried about back at Los Alamos, and that the PMP thought experiment highlights so starkly.
So this isn't just about faster computers or free software. It's about a fundamental shift.
It's about shifting the trajectory, propelling humanity forward, not just technologically or economically, though the implications of zero marginal cost and abundance are profound, but also socially and creatively. They talk about a future where basic needs are met, freeing us up for sports, wellness, arts, and spirituality. And crucially, aiming to fill the gap between the 1% and the 99%. It's about using this power for collective uplift, not concentrated control, a paradigm shift for stability.
So, okay, we've covered a lot. GridSAT, the Fermi paradox resolved, perhaps, NHI, this potentially reality-altering NDP technology, the dangers of secrecy. What does this all mean for us, listening to this right now, as we maybe stand on the verge of, well, something huge?
That's the question, isn't it? If advanced NHI exists, having likely mastered technologies like this, and if humanity is now potentially unlocking similar capabilities, how do we, collectively, ensure this becomes a path to advancement, to a better future, rather than just another way to stumble into a great filter? Maybe just having this conversation, this deep dive, understanding the stakes, maybe that's part of the answer. Realizing that when it comes to knowledge, this powerful, perhaps truly, there is no gift if it is not shared. Something to think about.